Hey there, my fellow intellectuals. Dr. Kyle here with another video, and tonight what I'm going to do is I'm going to demonstrate to you the power of dimensional analysis. Dimensional analysis is a very powerful tool that should be taught earlier in your physics education, but from what I've seen is often glossed over or not emphasized nearly enough. It's a powerful tool because it helps you constrain the form of the equations that you should be using, and we're going to go through a problem to help illustrate what this means. So let's take a look at the following problem here. The drag force on a sphere moving slowly through a viscous fluid depends on the viscosity of the fluid eta, which has the units of kilograms per meters times seconds, the radius r, and the speed v. Which of the following quantities is the drag force, F drag? So you have 5 options here, A through E, and by using dimensional analysis, you can easily determine which one of these multiple choice answers has to be the correct one. So the way to do it is to, first of all, read the problem carefully and realize that it's saying that F drag is only going to depend on these 3 quantities, eta, r, and v. Now, the way that I like to do these kinds of problems is I like to write them out in the following way. So let me get a different color here. I'll use light blue. And what we want to do, right, is we want to figure out what combination of eta, r, and v, that is, if we raise them to some powers, let's say alpha, beta, and gamma, what combination of these variables is going to be effectively proportional to the drag force. Okay, and this tool of dimensional analysis can get you these powers, but it cannot get you the numerical constants or dimensionless factors, right? So you can see here this dimensionless factor will be 6 pi, so that has no units, so we wouldn't be able to get that with dimensional analysis. But even still, just knowing what combination of eta, r, and v should be to give you the drag force is still a very great head start in terms of solving this problem and at least knowing what the functional form of F drag should be. So how are we going to do this? Well, we need to first understand what the units are that we're dealing with here. So when I use these brackets, that just means units of the quantity. So F drag, because it's a force, has units of newtons. And if you recall, I'm just going to think of Newton's second law here, F equals ma. M has units of kilograms. I don't know why I drew that arrow there. M has units of kilograms, right? So M is kilograms, and then acceleration is meters per second squared. Now, each one of these units can be broken down into sort of a fundamental general unit, because kilogram is a unit of mass. Meters is a unit of length, and seconds is a unit of time, but it's squared. So this is actually a unit of t squared. So remember that when I write this down, this just means mass, length, and time, ml and t. So these are the fundamental base quantities that we're going to build all the other units from. So if we use the MKS system, meters, kilograms, and seconds, then MLT are the fundamental building block of any other unit in the system. So for example, newtons, right? Newtons can be thought of as a mass, like we said over on the right-hand side here. It's a mass because it's a kilogram times a length. And then we're multiplying by a time to the minus 2. Okay, so this is what force generally has to equate to in terms of its units. It's a mass times a length times a time to the minus 2 power. And so when we write this, one thing that we should, or not one thing, but the thing that we should do is when we write eta to the oh, I wrote gamma twice actually here. That should be an alpha. So apologies there, that should be an alpha. So we should write eta to the alpha, r to the beta, v to the gamma. The units of all of these things has to equal an mlt to the minus 2. So again, what is the units of eta? Well, eta has units of kilograms, meters times seconds. So kilograms, meters over seconds, that's a mass. And then let's see here, it's a kilogram, meter is a length, times a time, because that was seconds, just going back up here. And all of that needs to be raised to the alpha power. Now the units of radius is a length, right? It's just a single unit of length, so that's just L, but we raise that to the beta. And then velocity has units of length over time, and we raise that to the gamma. And again, all of this needs to equal mlt to the minus 2. So we just need to combine like terms here. So again, rewriting everything, I'm just going to distribute the powers to all of the terms in the numerator and denominator. So we'll have m alpha, L to the minus alpha, t to the minus alpha. That's just from the eta term. Then we'll have L to the beta from the radius term. And then from the velocity term, we'll have L to the gamma and t to the gamma. That is gamma, right? Alpha, beta, gamma. Okay, yeah, just making sure in my head here. And again, all of these terms have to give us m to the 1, L to the 1, t to the minus 2. So the way that we do this, again, going step by step here, we're just going to combine all the like terms. So there are actually there's 3, looks like L's. So there's 3 L's here. And all of those L's, right, we should have L to the minus alpha, L to the beta, L to the gamma. That needs to equal L to the 1. Conversely, we could just say that negative alpha plus beta plus gamma is equal to 1. M to the alpha is the only M term. It's the only term that depends on mass. So here's M, and here's M. So we can say M to the alpha is equal to M to the 1. That's easy because we can just see that alpha needs to equal 1. And then we have T to the, let's see here, we have T to the minus alpha and, oh, I should have written that as T to the minus gamma right there, but it's the same thing. So T to the minus alpha minus gamma, and that needs to equal T to the minus 2. So we can say from that that minus alpha minus gamma equals to minus 2. Okay, so what are we going to do here? We can do some substitution. We know that alpha is equal to 1, so we can plug that in right there. And we can say that negative 1 minus gamma is equal to negative 2. Negative gamma is equal to negative 2 plus 1. And so negative gamma should equal, negative gamma should equal to negative 1. And so gamma should equal 1. So let's circle that. Let's also circle the fact that alpha is equal to 1, just so we can keep track of that. And the last thing we need to have is the beta, right? The beta term up there. So I'm just going to rewrite it as negative alpha plus beta plus gamma is equal to 1. We know that alpha is 1 from our previous results. So negative 1 plus beta plus gamma is equal to 1 is equal to 1. So negative 1 plus 1 is 0. So beta is equal to 1. Great. So we have all of our unknown constants now known. So we know that alpha equals beta equals gamma, which is equal to 1, which means that the powers of eta r and v should all just be 1, right? So we know that f drag is proportional to something that has eta to the 1, r to the 1, v to the 1, okay? And so if we look at the answers that were given in this multiple choice, we need something that has all the powers to positive 1. Looking at all the possible answers here, there's only one answer that has eta r v all raised to just the 1 power. Everywhere else you see something is either squared or has a negative power because it's in the denominator. So you can easily tell it is just C as the quantity that represents the drag force. So that is the conclusion to this problem. I hope it was clear. I hope you were able to get something out of it and see the power of dimensional analysis. And we'll be doing more problems to highlight, again, how this is a useful technique and how it can help you, solve physics problems, and also just sort of think about how physics and math connect in terms of we use math to describe physics, but the physics of the systems really constrain what the form of our equations should be. So with that, thanks for watching. Like and comment and subscribe if you thought it was useful, and I'll see you in the next video.